So, welcome back. How's everybody doing?
Oh, just great.
What were we supposed to do on Friday last? Yeah, homework quiz. Guess what we're doing today? The homework quiz. Okay. So, just as a reminder, the homework quiz was going to be with, or using section 6.1, or I'm sorry, 13.1, 6.1. So could you graph something on your calculator? And you could draw the picture on a piece of paper? And could you use your calculator to find the locations of the x-intercepts? And can you find the locations of the relative maximum minimum? You second trace and then use the max or min command. Yeah, exactly right. Okay. And so if I have a polynomial like this one, and I ask you how many zeros could there be, you'd answer close. At most 4. Yep, up to 4 would be fine also. Good. And then how many extrema? At most 3, one less, right? Everybody's cool with that? Again, pretty easy. Could you be able to write the end behavior using the limit notation?
I don't know.
Like that?
Okay. So if I'm looking at this picture, so this is the part that's going to be the same for everything, right? There's two things we need to fill in. Are those two spots? If I look at this end, the x is positive or negative? Positive, so I'll write down here, positive infinity. And the arrow's pointing which direction? Up, so that means the y is positive, so write positive infinity. What would I do for this one? Yeah. That's it. That's all you're doing is you're looking at the picture and writing down what you see. You're just using that notation.
So then the f of x is just y.
The f of x is just whatever the function is that you typed in there. But oftentimes we'll just say f of x because we understand it to be whatever the function is that we've been working with. But that, in this case, that f of x is whatever this is, like x cubed plus 1 or something. I don't know. Everybody's okay? That's the gist of it. That's 6.1. Those are all the things that we did in there. Yeah.
What about from a table? Don't we have to do that?
Yeah, that was in 6.1 also, but I wouldn't worry about it right now. I'm worried at this point, can you use the notation from a picture would be okay. What do you guys think? That's the gist of 6.1. Does that seem doable for a quiz? Yeah, right? It's no big deal. All right.
Wait, it's second trace.
Yep, that's where all the special commands live.
Yeah. That's the next class. On what?
I don't know.
I haven't finished any of them. Okay.
All right, so let's... Yes, of course. So let's do section 13.4. We'll finish this guy up. And then we'll talk about courses for next year. And then we'll take the quiz. Sound okay? I'd rather do it in this order. That way, like when you're done, you can just like work on your other stuff rather than like having to wait for everybody to get done to move on. You know what I mean? I just like putting it at the end for that reason. Okay. So you remember how we said just a moment ago in 6.1 we observed that the number of zeros is at most the degree? Right? We said that just a moment ago. We can actually do a little bit better than that. So the fundamental theorem of algebra is going to state for a polynomial of degree n, we have exactly n complex zeros, assuming that you're counting the repeats also. So what does complex mean? Mean you can have like real numbers and imaginary numbers. We have to count both kinds of solutions. But if you count all of them and the repeats, you're going to get exactly n solutions every single time. That's pretty cool, right? Tells you exactly how many solutions you can have. It's not a, oh, it could be this many or less. It's no. It's exactly this many every single time. That's pretty cool. The next piece that we have, since we can start having these complex zeros, is we also have this complex conjugates theorem. So it says that if I have some complex solution, a plus bi, I also need to have the complex solution a minus bi. That these complex solutions are always going to come in what are called conjugate pairs. So conjugates like just has the different sign in between the two terms. So a plus bi, a minus bi. So let's look at a place where we can apply this complex conjugates theorem. Oh, that's not where that was supposed to land. So this says, write a polynomial of the lowest degree possible that has zeros of 1, -3, and 1 plus I root 2. Remind me again, what is I equal to? It is an imaginary number, that's true, but what is it equal to? Anybody remember? It's from Algebra 2. You did it last year. Close. It's the square root of -1, which means that I squared is -1. Yeah, there you go. Okay. So again, you did that last year, but let's refresh our memories because it's been a minute. Okay, so back to 16. This sounds just like a problem that we did before, right? We did this problem in the homework. You guys remember doing that? Remember how we started doing this? Well, we started by writing down our solutions. And because this is a complex number, I should say is an imaginary number, I know because of the complex conjugates theorem, I also need what other solution? 1 minus I root 2. So because that is an imaginary solution, I know that it has to have a conjugate pair to go with it. So I'm going to write that down on my list also. Even though it wasn't given to me in the problem, I know it has to be there. Okay, so I know that these 4 things are solutions. So what I'm going to do then is I'm going to turn them into equations that are equal to 0. And I'm going to subtract those pieces over like this. Rather than one term at a time, I'm going to subtract it all as one piece. You'll see why I want to do it that way in a few minutes. It just makes the arithmetic a little bit easier later on. You don't have to do it this way, but I think it makes life easier. Everybody kind of remember doing this? What do we do next? I'm going to multiply all the left-hand sides of these equations together, and then multiply all the right-hand sides together. Is everybody okay with that? So what I have now is a polynomial whose solutions are these guys. All I have left to do is to multiply this out. How do you suppose I'm going to multiply this out? I'll multiply those guys together, and then I'll multiply these guys together. Very important that you're multiplying the 2 conjugate parts together. Good things happen there. It makes life much, much, much easier if you choose to do it that way. So I'm just going to FOIL here. I'm just going to do that one quickly in my head. Is everybody okay with that? This next one I'm going to FOIL slowly and carefully all together so you guys can see what's happening. Is everybody okay with that? So I'm going to do x times x. That's x squared. Then I'm going to do x times that whole quantity. Bless you. I'm going to just write it that way. And I'm going to do this one. And I will do that one. Everybody okay with how I FOILed that second part out? Okay. Next thing I'm going to do is just distribute these x's through. What am I going to have to be careful about there? What's in front of the x? Yeah, Matt? Sure thing. Have a good day. Well, there's the negative sign, right? Got to be careful I'm taking that with me. And then that last piece I'm going to FOIL. What do you notice about that last FOIL problem, though? That's a difference of 2 squares, isn't it? So I can use a shortcut to FOIL that out, right? That's just going to be a squared, where the a is 1, minus b squared, where the b is I square root 2. So far, so good? Okay. What's 1 squared? 1. What's, when I square root a, or I'm sorry, when I square a product where I have I times the square root of 2, how do I square a product right like that? How do I do that? What's the algebraic rule for how I do something like that? You have to square everything in the product. So you have I squared times square root 2 squared. And what is I squared the same as? -1. And what is the square root of 2 squared? 2. So that's all going to turn into then 1 plus 2 or 3. All right. So let's look at what we have now in this last big set of parentheses combining some like terms. I have a negative x. Ooh, what do you notice here? Canceled out, didn't they? Yes! No more i's. What? I didn't. I got 3 from 1 minus -1 times 2. Wouldn't that be 4?
Sorry. Wait, 1 minus -1.
You have to do the order of operations, so you multiply first. So -1 times 2 is -2, and then 1 minus a -2 is 3. Okay, right. Minus a -2 is +2, right? No, it's okay. It's been a while. For a little rusty, that's okay. It happens, guys. It happens. Oh, shoot, guys. I got one little boo-boo here to fix. So notice here that, let me get a highlighter maybe. Notice that this is a negative and this is a negative. But what did I write here? That should be a positive there. Sorry about that. Yes, of course. So that should be +3. All right, what do we have to do next? More foiling! Oh my gosh. X squared times x squared is x to the 4th. Yep, go ahead and shout them out. X squared times negative 2x is negative 2x to the 3rd. X squared times 3 is 3x squared. 2x times x squared is 2x to the 3rd. Good. 2x times negative 2x is good. 2x times 3 is 6x, or 6s. Haha. Negative 3 times x squared is negative 3 times negative 2x is 6x. And then negative 3 times 3 is negative 9. Okay? So let's go ahead and combine all the like terms together. What did we have here happen? I have x to the 4th. Then I have a negative 2x cubed and a positive 2x cubed, so those just canceled out. I have a 3x squared, a negative 4x squared, and a negative 3x squared. That gives me negative 4x squared. And then I have a 6x and a 6x. That gives me a 12x. And then I just have that minus 9. So there we are. Woo! As a workout. Want to hear the good news here, folks? If this is a 4-point problem, getting to here is like 3 out of 4. So foiling it out is just like the 1 point at the end. That was where all the work was. So you can get 75% of the way there. That ain't bad. Right? All right. The other kind of problem that you're going to be expected to be able to do is one like this. So this says find all the zeros for the function. When we say all, what do we mean? Means real and imaginary, right? So in this problem, how many total should we be looking for? 3, exactly 3, right? So, well, what do? We start by setting it equal to 0. And then we observe from the fundamental theorem of algebra, we know we're looking for 3 solutions. Right? And then we're going to use our rational roots theorem to come up with some possible solutions that we could use synthetic division to get. So to use the rational roots theorem, I need the factors of the constant term. What's the constant term for that polynomial? $36. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, 36, right? And really all of these are plus or minus. And then I'll need the leading coefficient. What's the leading coefficient for this? For this polynomial, what's the leading coefficient? Not 3. That's the degree. 1. Well, that's nice. What are the only factors of 1? 1 and negative 1. Okay. So my possible rational zeros then are going to be the factors of the constant term divided by the factors of the leading coefficient. So since the leading coefficient factors are just 1 and negative 1, it's basically just the factors of the constant term. Everybody's okay here? So what I'm going to do is I'm going to do some synthetic division using some of these numbers from this list. Well, Mr. Kulik, I don't know, there's like 24 numbers or something with all the, if we're counting all the pluses and minuses, like which one do I want to start with? Because how many can work? At most 3. Right? We don't know we don't know all the solutions are going to be rational. We know at most 3 will work. Well, that's pretty lousy odds. Can we do anything to narrow this list down a little bit more? When I was a student, this process was quite tedious and not so fun. You guys as a student have a much more powerful tool than I had. What you would want to do is you just want to type your function into your graphing calculator. And then we're just going to zoom standard graph that. And we're going to look at the x-intercepts. How many x-intercepts do you see? 1. What's that x-intercept at? Negative 4? You guys agree? Is that number on my list? Sure as heck is. That means that I should do my synthetic division using that number. What if I got a number that wasn't on my list? Don't use synthetic division on it. It should not work. Okay. So so the negative 4 goes outside. That's what I'm going to be using my synthetic division with. What numbers go on the inside? 1, 4, 9, 36. Where are those numbers coming from? They're the coefficients from the problem, right? What's the one thing I have to be real careful about when I'm writing those numbers in? Yeah, if I'm missing a term, I have to include a 0. Yes, critically important when you're doing synthetic division that you're careful about that. What's the trickiest term that Mr. Kulik can leave off? The constant term at the end. Because it looks like they're all there because it goes, oh, third, fourth, third, second, first. And there's nothing that I skipped. It's like, if I skip the last one. Whoa, that's tricky, Mr. Kulik. All right, we begin our synthetic division by just bringing the first number down. Then what do we do? -4 times 1, and we write that in the next spot, and we add down, and we just keep on going. What are we looking for to have happen? We're looking for a 0 at the end. That tells us it worked. So what we can say then is that our polynomial is going to factor to x plus 4 because -4 gave us remainder 0. So I know x plus 4 is a factor. And then what's the other factor? Well, we're going to get the other factor from these other numbers at the end of my synthetic division. Remember, this last number is the remainder. It's the constant term, the x coefficient, the x squared. So these numbers give us the other factor. I didn't write 0x there because, well, it's 0x, right? I just wrote x squared plus 9. If you want to write 0x there, it's not wrong. I'm just not going to do it. Everybody's cool? So now, remember that this is all equal to 0 still. Look at our two terms. X plus 4 is linear. Can I solve a linear term equal to 0? Definitely. X squared plus 9 is quadratic. Can I solve a quadratic equal to 0? Definitely. So I'm done with my synthetic division because I have two pieces that when I apply the 0 product property and set them each equal to 0, I can solve each one of these two independently. So I can solve x plus 4 equal to 0 just by subtracting 4 from both sides. Well, Mr. Kulik, no kidding, -4 is a 0. I knew that already. Cool your jets here, guys. Cool your jets. How am I going to solve x squared plus 9 equal to 0? How do you want to do that? Okay, we can subtract 9 from both sides and then square root both sides. When we square root both sides, what do we have to be careful about? Or what do we have to have? Plus or minus, very good. When you square root a negative, what do you get? Whenever you square root a negative number, what do you get? Nope. And yeah, that's what we're talking about. So I know there's an I at the end of this. And then what's the square root of 9? 3. So I have plus or minus 3i. How many solutions am I supposed to have? 3. How many do you see? There's 3 there. So x minus 4 is 1. What are the other 2? Positive 3i, and then the third one would be negative 3i. So remember, the plus or minus is really 2 solutions there. So we're done. That wasn't so bad. Really no worse than the problems like this that we had done in section 13.3. Let's do one more. take a minute, try to work on this on your guys' own. We'll give you 5 or so, 10 minutes, something like that, and then we'll go through it together, okay? Okay?
Yeah.
Okay. Uh-oh, students. There's a power line down on Giddings.
We should have just left school early. I don't know why they didn't have us.
Everyone has to turn right on Giddings if you're going that way.
What does that mean? Why didn't they just have us leave early? I can't go straight. Wait, no.
Right, it was straight.
Out of the parking lot.
Josh.
You okay? I think it's
You're
late.
gonna drive to the
No,
tree.
wait, hold up. What way do I usually go? Oh, I usually go left. I'm all the way down. I go all the way around. Okay, come on. That's so nice.
I don't think they do. It was like a.
Are the roads bad? Do you know, Mr. Coolidge? I'm assuming.
I don't, but I can't imagine they're great.
I mean, it was raining all day and now it's like 30 degrees, so I feel like it's gonna be all
I feel like the
ice.
cops would have been involved.
I mean,
The cops didn't do anything about it.
potentially.
Didn't Clarkson get out earlier than a bunch of other schools?
I don't know anything about Clarkston, but maybe. I wouldn't have come to school today, but they didn't ask me.
No, it was there. Yes.
Clarkson and who? Clarkson and what other district? Oh, I don't know. Okay, I think it's another. Wait, when did the bond say that? I don't know. Was it
Yeah,
recent?
last one.
That's so weird.
And I guess what? You got me.
Why do we want little dog? Yeah, that would be so funny. I asked him, I was like, what days do you think this weekend? Because I'll be at the dance, so I'll try to stay for last Friday. Oh, I don't know, yeah, it's to stay for last Friday. He was like, that. Oh!
Do. How are you guys doing on this? Are you guys as far as I am? I gave you a head start. There's a lot of chit-chatting going on for people that don't seem like they've gotten very far. At least with your math homework. It sounds like your Clash Royale or whatever you're playing is going quite well, though. Oh, chest. That's my favorite game.
That's why I like playing. It's very strategic.
Did you like that I mispronounced it though and called it chest?
Yeah. I was gonna make mention, but
You have to know what it's called.
I'll ask a little bit.
Oh, no.
All right. So I came up with this gross looking long list. I go look at my graph. I can't really tell where these are crossing because they're not happening at tick marks, right? So I'm going to adjust my window a little bit to get a better glance. Looks like everything is going on between -2 and +1 to me. So I'm just going to change my window. What does this 0 appear to be? Look at my mouse. What does that 0 look like? Well, this is 1 here. Looks like a half, right? Okay. Is a half on my list? Yeah, right? Okay. What's this one look like? What does this one look like? What does that decimal look like? About 1.25? 1 1/4? That seems reasonable to me. Oops. You may. And as, but negative, right? Good goodness. Is that on my list? Yeah. Okay. Well, both those look good then. Let's start synthetic division. Which one do you want to start with? Does it matter? Probably not. I say probably not because in rare situations it might matter, but not ones that you'd expect to see in this class. All right. Looks like it worked. But what's the catch here? What degree polynomial is this stuff going to be? That's a degree 3, right? Because I had a degree 4. I just divided it. So I should get a degree 3 back. Shh. Do you guys know how to solve a degree 3 polynomial? Probably not. There's not really a formula to do that. So what am I going to do? I'm just going to divide again with negative 1.25. So what's that? Negative 10. And then that's going to be 40. Oops. Sorry, positive 40. 56. And then that is negative 70. Okay. So that worked. And then what kind of polynomial is this? Quadratic. Can we solve a quadratic? You betcha! All right. So what are the factors that we have? We have x minus a half. We have x plus 5/4. And then we have 8x squared minus 32x plus 56. Is that okay? If I set this one to 0, what's my solution? Yep. If I set this one to 0, what's my solution? Anybody tell me the solution to this set equal to 0 without really doing some algebra? I can't either. Okay, what are we going to use to solve that one? Probably not. I don't think it's going to be factorable. What else could you use to solve it? Quadratic formula? Yeah, let's get rid of the 8. That's a good idea. Regardless of what we end up doing, that'll make life easier. Notice because it's an equation, I didn't have to factor the 8 off. I could just divide both sides by it and get it. Get out of here. Now note here, at least, there's not two numbers that multiply to give us 7 and add to give us -4. So factoring's out of here. So quadratic formula it is. What's the equation? -b plus or minus square root b squared minus 4ac all over 2 times a. Is that something I expect to have that you have memorized? Yup. (16 minus 28 is -12. What's the square root of a negative going to have? We're square rooting -12. I, because it's got a negative. How do I simplify the square root of 12? Square root 4 times square root 3, right? Why is that helpful? Because the square root of 4 is 2. Yep, absolutely right. So I'm going to put the 2 there and the root 3 there. Can I reduce that? Why? Yes. How do I know I can reduce it? Nope. You have to divide both parts of it by the 2. So that reduces down. That reduces down. So it's 2 plus or minus I root 3. You said 2I root 3. Don't act like you didn't. That's what I said. No, it wasn't. I was listening carefully. It's okay. I know what you meant. How many solutions was I supposed to get?
4.
How many do you see? There are 4. There's one here. Second one's here. Yeah, because the plus or minus, there's solutions 3 and 4 are written together. 2 plus I root 3 and then 2 minus I root 3. Everybody feel okay there? Okay. Let's take a quick minute and talk about courses for next year. I think you guys do course selections this week.
Oh, great.
Isn't that exciting? So I made on their My Notre Dame page, I made a little announcement here. So this is just going to be, this is what I'm going to be talking about here. I just made some notes on this, so if you forgot what I'm saying now or you weren't paying attention, it's there in one place for you. So there's like 5 possible courses. 2 of them ostensibly have no prerequisites. The other 3 have pretty heavy prereqs. So the first 2, you have math applications and personal finance. There's no prerequisite to that. It's a 4.0 scale class. It's 1 semester for each of those parts. Accounting 1 and 2 count as math classes. Your prereq is the completion of Algebra 2, which you all have done because you're here. The next one is the IBSL course. That has a prereq, A- or better from both semesters of this class. First half of that class is a lot of stat. Second half is like a hodgepodge of like assorted topics, some of them coming from like Algebra 2, Trig Pre-Calc, maybe things you haven't seen yet. That course moves fast though, just letting you know. It's not hard. I don't think it's much harder than this course is, but it's fast. And then there's AP Stat and Calc. Both of those are, for you guys, are by my recommendation only. AP Stat and AP Calc. Going to there from this class are by my recommendation only. My recommendation is you basically need to get A's on everything. Not just A's at the semester, but like all A's on like everything you've done. Because these are AP math classes. We're not messing around. They're going to be real hard.
Do you teach that?
I teach the AP Calculus course right now. I think Miss Garcia's will teach the AP Stat class. Okay. If you're a current senior, do you have to worry about this? No. I would say the one other thing with the SL or the IBSL course, if you're a diploma program student, you're taking that regardless of what you've done in here. So get ready because it moves quick. If you have individual questions about stuff, I'm happy to answer those. But all this stuff is on the My Notre Dame here also for you guys. So I'm going to pass out your stuff for the quiz and we're going to get rock and rolling. Cool?